how effective attention was. How
Self-attention?
Self-attention,
Yeah.
the thing that led to the transformer and everything else, like this explosion of
Yeah.
intelligence that came from this
Yeah.
idea. Maybe you can kind of try to describe which ideas are important here, or is it just as simple as self-attention?
So I think first of all, attention, like Joshua Bengio wrote this paper with Dimitri Badano called soft attention, which was first applied in this paper called Align and Translate. Ilya Sutskever wrote the first paper that said you can just train a simple RNN model, scale it up, and it'll beat all the phrase-based machine translation systems. There's no attention in it. And then this grad student Badano in Bengio's lab identifies attention and beats his numbers with way less compute. Then people at DeepMind, they figured out that a completely convolutional model can do autoregressive modeling as long as you do masked convolutions. The masking was the key idea. So you can train in parallel instead of back propagating through time. You can, and so then Google Brain, like Vaswani et al., that the transformer paper, identified that, okay, let's take the good elements of both. Let's take attention, let's take the insight and WaveNet and combine the two together. And they built a transformer. Nothing has changed since 2017. I think the insight then OpenAI took from that is, hey, like Ilya Sutskever was been saying, like unsupervised learning is important, right? Like they wrote this paper called Sentiment Neuron, and then Alec Radford and him worked on this paper called GPT-1. It wasn't even called GPT-1, it was just called GPT. Little did they know that it would go on to be this big. But just said, hey, like, let's revisit the idea that you can just train a giant language model and it will learn natural language common sense. That was not scalable earlier because you were scaling up RNNs. But now you got this new transformer model that's 100x more efficient at getting to the same performance, which means if you run the same job, you would get something that's way better if you apply the same amount of compute. And so they just train transformer on like all the books, like storybooks, children's storybooks, and that got like really good. And then Google took that insight and did BERT, except they did bidirectional, but they trained on Wikipedia and books, and that got a lot better. And then OpenAI followed up and said, okay, great. So it looks like the secret sauce that we were missing was data and throwing more parameters. So we'll get GPT-2, which is like a billion parameter model, and like trained on like a lot of links from Reddit. And then that became amazing, like, produce all these stories about a unicorn and things like that, if you remember.
Yeah.
And then like the GPT-3 happened, which is like you just scale up even more data. You take Common Crawl and instead of 1 billion, go all the way to 175 billion. So I think that ended up being the breakthrough, right? Like this, it's not like attention alone was important. Attention, parallel computation, transformer, scaling it up to do unsupervised pre-training, right data, and then constant improvements.
Well, let's take it to the end because you just gave an epic history of LLMs and the breakthroughs of the past 10 years plus. So you mentioned GPT-3, so 3.5. How important to you is RLHF, that aspect of it?
It's really important. It's, even though you call it as a cherry on the cake.
This cake has a lot of cherries, by the way.
It's not easy to make these systems controllable and well-behaved.